For my deep dive, I made a program that finds the most cost-effective path of flights between two given airports in a variety of ways. I used Dijkstra's algorithm to compute the shortest paths based on a whole lot of data that I hand-collected. This is definitely a shortcoming of it, because I collected the data for a specific time window during a certain time, and airline prices can vary greatly on different days. I gathered the data a couple months ago by now, so it's probably very different by now. I also only got one price for each flight, since I realized after a while that it would take even longer if I averaged prices for every single one of those 630 flights, 210 flights 3 times. I looked at flights from May 16th to 23rd for Southwest and United Airlines, but I couldn't book that far out with Spirit, so I looked at February 21st to 28th for that instead. I also found how long each flight between each airport would take on average from flightsphere.com in order to calculate a ratio of price versus time. I wanted to make a visual of all possible flights versus which ones each airline had available. As my comparison, I connected every one of my airports to all of the others. I then went through all the flights that I was able to save data for Southwest and drew only those. I then did the same with United, which seemed to have the most evenly spread variety of flights. I then did the same with Spirit, which had significantly less available flights, but that may have also been because of the timing I was looking at. I also have an image of all the flights of each airline overlaid over one another in the, quote, all possible flights graph. Doing this did give me some interesting information. United definitely had the most flights cross-country, with it all being quite evenly distributed. Southwest has a few main airports that a bunch of flights need to have layovers at, such as Chicago, so most flights get routed those ways and then to their destinations instead of direct. Spirit was very much lacking in any northwestern cities and just had very limited flights overall. Because of this, I knew I couldn't calculate shortest paths to those cities with Spirit alone. I was also able to use this to easily check which cities airlines didn't have direct flights between, so I could use my shortest path algorithm to find those. Now I'll break down Dijkstra's algorithm. The basic idea is that it makes a queue of neighboring points saved with priority based on the, quote, cost to reach them, then continues to update it as it traverses through the best option each time. Once it reaches the goal, it traces back through that path and returns it. For my project, instead of saving one cost for each connection, I passed in a list of 4 values: length of flight, price for Southwest, price for United, and price for Spirit, saving unavailable flights as null. Then, based on the preference entered, Southwest, United, Spirit, etc., the code would set a value, quote, parameter from 1 to 5. It then starts looping through neighbors of the current point and updating it as it goes. If the parameter was 1, 2, or 3 and the value wasn't null, it would go through the first if branch. I also made a variable called newdist that new distance that held the value of the current point plus the weight of the path to whichever neighbor it was looking at. If this new distance was smaller than the currently saved shortest path, it gets added to the queue as the new highest priority. If the parameter was 4 or 5, it goes down the else if branch. It makes a list of the 3 airlines' prices, then picks the smallest one. If the parameter was 5, it goes into another loop to divide that min price by the flight time. Newdist was updated, adding that new min price variable. It then does the same check of if the new value is smaller and adds it to the queue if so. Once the program reaches the goal, it's able to trace back to the beginning via the previously saved prev nodes. Once I finally worked out all the kinks, I was able to call my function with various cities and parameters. I also implemented a simple user input where it asks the user where they're starting, where they want to go, and what airline they prefer, then returns the best path. I made it loop infinitely until cancel is entered so that users can do different searches without running the program all over again each time. This project was a lot more time consuming than I expected. I started out with way more cities, but then once I started filling out values, I realized I really had to cut it down. I cut it down once, and then it was still way too many, and then I cut it down again, and it probably was too many, but I also only got the price for one direction for each flight because the first few that I looked up, it was pretty close, and I was already looking up like hundreds of flights, so I really didn't want to look up both ways. So that might be a little bit of like inaccuracy based from real life, but close enough. The code also ended up having a fair number of bugs, often going into infinite loops, but eventually I fixed those problem areas. Yeah, so that's what I did. Yippee.